7.6. Solve logarithmic equations.
Logarithmic equations are equations that involve logarithms of variable expressions. Property of equality. If b, x, and y are positive numbers with b not equal to 1, then log base b of x equals log base b of y, if and only if x equals y.
You can solve a logarithmic equation two ways.
A, using the property of equality, or B, making each side of the equation an exponent using an appropriate base. So we're going to be solving the first logarithmic equation with the property of equality. This equation states log base 4 of 5x minus 1 equals 3. And what you're trying to do is convert from log form to exponent form. So you get 4 cubed equals 5x minus 1. You work out your 4 cubed and you add 1 to both sides. So you get 65 equals 5x. You divide both sides by 5 and you get x equals 13. But you're not done yet because you have to make sure to check your answers. Why? Because you're in Algebra 2. So when checking, put in what you got for x into the equation and solve. Using appropriate bases and exponents. Log 2x plus log x minus 5 equals 2. These are common logs, which means they have no subscript. So the base you choose is 10, which cancels out this log and cancels out this one. And since you use base 10 on this side, you have to apply it on the other side too. So you get 2x times x minus 5 equals 100. You solve it by subtracting 100 on both sides, and you get 2x squared minus 10x minus 100 equals 0. And you automatically can find a common factor, so you take out 2 from each. You have to always make sure to check for extraneous solutions. So we factored it and we took 10 and plugged it into our original equation. We did the math and we said that we were right. We didn't try using x equals negative 5 because x equals negative 5 is extraneous. You can't take the log of a negative number. So we're going to show you one more simple example and then another harder one. So this equation states log base 4 of 3x equals 6. So you get 4 to the 6th power equals 3x.
No problem.
Once you do your math, you get 4,096 equals 3x. You divide both sides by 3, and you get x equals 4,996 equals 3. So this equation states log base 6 3x plus log base 6 x minus 1 equals 3. What you're going to try to do is make each side of the equation an exponent using an appropriate base. So you're going to get base 6, log base 6, 3x plus 6 log 6, x minus 1 equals 6 cubed. So these cancel out and these cancel out. And you get 3x times x minus 1 equals 6 cubed. 6 cubed is 216. And once you do the math, you get 3x squared minus 3x. What you're going to do is subtract 216 from both sides. So you get 3x squared minus 3x minus 216 equals 0. You can take out a 3 from the whole. So once you're done dividing this by 3, you get x squared minus x minus 72 equals 0. And the next step is to factor it. So once you try factoring x squared minus x minus 72 equals 0, you get x plus 8 and x minus 9. So what you have to do next is check for extraneous solutions. So you get x equals negative 8 and x equals 9. And you have to check with 9 because you can't take the log of a negative number. So to check, you just plug in 9 where x is. So you get log base 6, 3 times 9 plus log base 6, 9 minus 1 equals 3. So you get log base 6, 27 plus log base 6, 8 equals 3. And since it's addition, you multiply. So you get log base 6 of 216 equals 3. And you get 3 equals 3.